Right, well, my class tried to do this question. I had a little bit of trouble with it. This question is from a Cambridge exam, Pure Math 3, February, March 2022. It's question 5. So if we look at the question, it says the angles of alpha and beta lie between 0 and 180 degrees, and it's such that the tan of alpha plus beta is 2, and the tan of alpha is 3 tan beta. Find the possible values of alpha and beta. Right, the first thing to note is just we have two equations and we have two unknowns. And so right back to basic principles, we just have to find solutions that work for both of these equations. And so we're talking about simultaneous equations and finding the solution, which is either by substitution or elimination. Substitution looks like it's definitely the way to go. So let's label our equations. We'll call this one equation 1, we'll call this equation 2. The tan with the a plus b on the inside is causing us a lot of problems, but we know a trigonometric formula that's going to help us with that. And so that should be the first thing that we do. We take the tan of alpha plus beta, and we're going to convert it into a form where we don't have alpha plus beta. But we do have formula sheets that we can use in the Cambridge exams, and so this will become tan of alpha plus the tan of beta divided by 1 minus the tan of alpha times the tan of beta. Okay, so that looks a whole lot nicer because there's a bunch of alphas and betas. So we can take that, and our first equation, let's take the denominator up and multiply it by the 2. And so we'll rearrange the first equation now so it looks like this. Tan of alpha plus the tan of beta is equal to 2 times 1 minus the tan of alpha times the tan of beta. Okay, so that's our equation 1 just modified slightly. What's really handy about this is our equation 2 has tan alpha is equal to something. So we can just substitute that in. Wherever we see tan alpha, we can put 3 tan beta. And that's exactly what we're going to do. 3 tan beta plus 1 tan beta is equal to, let's expand the brackets at the same time, 2 minus, so it's going to be 2 times 3 tan beta, which is going to be 6 tan beta, multiplied by tan beta, which is going to become tan beta squared. Right, so we can see that a quadratic is forming here. And what we'll do is we'll take the squared term over here and so that it becomes positive. So it's going to be 6 times tan squared beta. We have 3 plus 1 is 4 tan beta, and if we bring the 2 over as well, it will become minus 2, and that equals 0. All right, so we've got a quadratic. We can try and solve it like this, or we can simplify it first. I always like to simplify them as much as we can. So divide both sides by 2, or we can factorize 2 out of all of the terms on the left, and then divide it into 0. And so we would end up with 3 tan squared beta plus 2 tan beta minus 1 equals 0. All right, we do a quick check to see if we can solve by inspection. 3 times negative 1 is negative 3. So does anything multiply to negative 3 and add to 2? Yeah, of course, 3 and negative 1. So they're the two numbers. And if we're going to do it the longer way, we would break the middle term up into those two numbers. We want a positive 3, right? Positive 3 tan beta minus 1 tan beta minus 1. And then we just factorize the first two terms. 3 tan beta. And we're left with just a tan beta plus 1. And so we subtract 1 and we'll get tan beta plus 1 equals 0. Of course, if you're trying to solve quadratics, you always have to factorize, use the null factor law to solve them. We do the next step, tan of beta minus 1 and tan of beta plus 1 equals 0. All right, so this gives us two possible results for the tan of beta. First one is the tan of beta is going to equal a third. And the second one, the tan of beta is going to equal to -1. Okay, let's take just a quick look back at the question, and we will find out that the angles lie between 0 and 180 degrees. That's for alpha and beta. So the only valid answers here for us are answers that are between 0 and 180. So for the first one, when tan beta is a third, we get our calculators and make sure our calculator is in degrees, because when they told us to give our answer, they were using degrees. And we do the inverse tan of a third. And we get 18.43. Okay, and because it's positive, we're in the first quadrant. And so we definitely have an answer where beta is 18.4. Typically, when you do Cambridge exams, they want angles in degrees to 1 decimal place. So we're happy to have that one. For the second one, we've got beta, well, 1. We know that when tan of 45 is 1, but in this case, it's negative. So 45 is not going to be an answer. Where is tan produce negative results? Quadrant 2 and quadrant 4. And so in quadrant 2, that's between 90 and 180 degrees. We will find that in this one, beta is 135 degrees. Okay, they're my two answers. And now I need to find the other variable, which is alpha. What we do know is tan of alpha is 3 times the tan of beta. And so we're actually going to go back and use the second last line, because that actually tells me what the tan of beta is. So in this case, finding our second variable, the tan of alpha is 3 times the tan of beta. The tan of beta is a third, and 3 times a third is just 1. And or for the second example, the tan of beta is -1, and so 3 times -1, tan of alpha is going to be -3. Okay, and so we're almost finished now. All we have to do is, well, what's the inverse tan of 1? The inverse tan of 1 is 45. And so for this case, alpha is 45 degrees. Now notice that this is a combination, alpha and beta, that actually make both equations true, because we were solving them as simultaneous equations. And for the second set, we're trying to find the inverse tan of -3. Note that because it's negative, we can't be in the first quadrant. And of course, my calculator gives me an answer in the fourth quadrant, -71. But to get our answer in the second quadrant, between 90 and 180, we just have to subtract 71 from 180, and then we get 108.434, round it to 1 decimal place, and we'll get alpha is equal to 108.43. Well, it's just 1 decimal place, it's actually 0.4. And there are two answers, and they come in pairs because we were solving 2 equations to get unknowns, 2 unknowns, and so they have to remain in pairs. So our first pair is alpha is 45 degrees, and let's try and beta is equal to 18.4 degrees. And our second answer, so we can write it all, alpha is 108.4 degrees, and beta is 135. Okay, I think that wraps up the question. I hope it helps you understand. Let's fill the screen up if we can. I hope it helps you understand how you should approach this and make it a little bit easier for you.